Okay, hello, my name is Olivia Forst, and today I'm going to be presenting an introduction to photogrammetry for emerging tech in game development. So the first question that we have to answer is, what is photogrammetry? And photogrammetry is the science of making measurements from photographs. So we'll see later on, you will take hundreds of photos in some stances, and with those photos you will the software that you use will be able to determine measurements and create actual 3D models from just these pictures. So what do you need and what do you get? What you need is hundreds of pictures, a camera or hundreds of cameras, as you can see in this right picture here, which is can be a typical photogrammetry setup. What you get is it can be a map, a drawing, a measurement, or a 3D model of some real-world object or scene. So whatever you take a picture of. So in this picture of the right is an example of photogrammetry. You can see each of those little rectangles are actually a JPEG image that had been taken, and you can see that they wrap around the image itself, or the sculpture itself. And with all of those images, the software is able to fabricate all the measurements and make the sculpture inside the software itself. So with just all these pictures, we are able to actually make a 3D model. So there are two different types of photogrammetry: aerial photogrammetry and terrestrial and close-range photogrammetry. So first, there's aerial photogrammetry. You can see the picture of the back. It is usually when a camera is mounted in an aircraft and it is pointed vertically to the ground. With this, they will take multiple pictures that will be overlapping, so it's not missing a spot of the ground as the plane flies along a set path. This is primarily used for when making up maps, things like that, or overtop images and views. Nowadays, it is commonly done with drones and UAVs because those are much less expensive than actually taking out a full plane. Next is terrestrial and close-range photogrammetry, which is what I'm going to be focusing on in my next presentation. It is when the camera is located on the ground, so not up in a plane. It can be handheld on a tripod or even pole-mounted, but with this, they take the camera and they move around the sculpture itself, or whatever your object is. And they can't move the object, so by moving around and taking pictures of each possible angle that they can from the object, they will be able to put all those images into a software, kind of like in the back, and get the 3D model and measurements of that object and have it in 3D space. So the output for these is not typically terrain, but instead it would be drawings or 3D models. If you would like terrain or topographic maps, that would be more aerial photogrammetry. And this can be done with any camera that is accessible, even a phone camera. So we're going to move on to photogrammetry in the game industry, which it is much more widespread than I originally anticipated. Many game developers actually use photogrammetry to make all different types of 3D objects. They can range from small handheld objects like bottles, guns, even rocks, to whole large-scale environments like cityscapes or mountains. They'll even be known to take specific buildings and take pictures of those and then input them in the game itself. The picture that you see is actually from the game L.A. Noire, where they took pictures from an actor and they were able to put his face into the game and make a model of it, just from the pictures itself. So these are pictures of the process to help you understand further. So first, as you can see in the back, you would have to take a picture from all angles. You can't move the actual object itself because that will cause issues. You don't want it to, you want it to be in its state. If you move it, it won't be the same for each picture. So you have to take multiple pictures from all different angles, anything that you can think of, and the more pictures that you take, ultimately the better the model will be. So then you would import those images into your photogrammetry software, and each of those rectangles that you can see are actually JPEGs, as stated before. So you can see that the images actually surround the entirety of these rocks, which is what the object is going to be. So yes, you import them into your photogrammetry software and it starts to build the object. So then it generates a dense 3D point cloud with millions of points. So this would be the object per se, right? It looks amazing and it looks real. However, it is extremely inefficient when in game. It has millions of points because it is looking for everything that was in that picture itself. So while it looks amazing, it's fairly unrealistic to have that in the game itself. So that leads us on to what is going to be happening in a few steps. Next, you will see that it generates a detail and heavy 3D object. These are kind of like normal maps and things like that, things that give us the grooves and the dents that we can't necessarily model ourselves. So from the pictures, textures can actually be generated. As you can see in the back, they have all different types of textures that were placed around in the images and that were actually on the model itself. So this leads on to, they hand this off to artists now, and artists have the job of making the model a significantly lower poly count, something that is more realistic in the sense of of rocks in a game. It's extremely unrealistic to have your rocks have millions of points and millions of polygons when they'll more than likely just be walked over anyway. But it's still important to have them look as amazing as they can possibly be. So the artists must go through and take out what they can and make the model more efficient. So afterwards, they would generate efficient texture coordinates. As you can see, each of those coordinates on the back would be where specific, where they would place the textures and where they would go. Then the artist would generate the textures from the source model onto the coordinates themselves, because textures don't take up as much as polygons and things like that. So you can have extremely realistic textures without taking too much from it. So you can just take those textures straight from the source model itself. So that's what they're doing. They put them on the coordinates so that when they are put back on the model, it'll be perfectly fine. Then with those same coordinates, they generate the normal maps that we're on, so that you can have all those bumps and grooves that were on the rocks. Next, this is optional for whatever you're making, but for this in-game asset, they actually made shaders that were created to match the feel for where this object is going to be, and etc. So these are shaders themselves. And finally, this is the final asset ready for in-game use. It is significantly lower poly. You can't really tell, but it is actually something that can be used in-game without breaking everyone's graphics cards. So here's another example. I have Resident Evil 7, Jack Baker. In the middle, you can see that Jack, that is the model that they have for Jack, the physical model. And they're taking pictures of him from different angles. You can see that there's cameras pointed at him everywhere, and you can even see that in the photographer's computer. So he's just standing there or sitting there with a straight face, and they're taking pictures. Next is that picture to the right of him, or right to the middle, and that is the actual model that they brought in themselves from the pictures. It's extreme. It looks just like him, and it's all done from the different angles of the pictures that they took. And all the way to the left, you can see that that would be where it generates kind of normal maps and things like that. Different parts of his skin that we can't necessarily model ourselves, or don't add the same level as of detail. So normal maps add more detail to those things. I actually put a link to a video itself. I'm pretty sure that it is in Japanese, but it's still interesting to go through the photogrammetry process with them themselves and make Jack Baker. So maybe asking why use photogrammetry in video games. Ultimately, games are being made now to be as reflective of reality as possible when it arises. Of course, if you're making a 2D game, say like Cuphead, for example, you're not necessarily looking for reality. You know, that's just your whole theme. However, with things like Call of Duty, Battlefield, even things like Final Fantasy per se, you want certain aspects of them to be as reflective, as real as possible, to truly immerse the players. A more immersive player is a player who enjoys your game more and who is willing to spend money on it. And ultimately, the more realistic the graphics, the more the brain can delve into the fantasy. It will be more difficult for a player to leave if they feel like it is more realistic. In the bottom right, I have a link to what I'm going to show off a little bit more next. And it is actually an Unreal showcase of photogrammic realism in Unreal. This picture of the right, you can actually see that they used photogrammetry to make the environment and the assets in it. So here's what I was talking about before, the Unreal Engine 4 photorealistic graphic showcase. This was made in 2019, and I have a link down in the bottom left. I truly recommend watching it. It's amazing to see what these artists and what Unreal was able to do with photogrammetry in these setups. So each of these images is taken from that showcase itself, and it shows off photorealistic graphics. These are all from pictures, and all of the things inside of it were developed from pictures themselves. At some points, I found myself, especially in the beginning of the video, wondering whether it was actually real or a game. It was amazing to see that these different terrains and things could be created with pictures. It was just jaw-dropping to see how realistic that it could get. So the future of photogrammetry in the game industry, I believe and I can see that photogrammetry will ultimately become more utilized and become more widespread. While photogrammetry softwares can be fairly expensive, it is not limited. Anyone can use it. And the higher, the more money a company is willing to spend, the easier that it'll just be. But you don't necessarily have to spend money to get these things, spend outrageous amounts of money for these things. But if you're a game company that makes millions of dollars, I'm sure that it'll be nothing for them. Ultimately, there will be more realistic games and models, and when companies use photogrammetry, they will realize that players will adore their photorealistic graphics and things in the game, and it'll get them likely more players in the long run. So, and ultimately, I think that photography and game development will become further entwined. I'm sure there are definitely instances of it now, but you can hire professional photographers, and they could take all these pictures of things, and they could give those to the game development company, and together they can work to create amazing 3D assets for a virtual space. These are just some photogrammetry programs. We have Reality Capture, Autodesk Recapture, and 3D Zephyr. There are plenty of more out there. I'm going to be focusing primarily on Reality Capture because it was talked about in class, and I've actually watched multiple videos on it, and it seems the best for my price range right now. So that's what I'm going to be focusing on. All of these are perfectly valid, and there are plenty of more that are used, especially by the professionals. So these are just some programs that ultimately push photogrammetry. So here are some examples that I have. I'm not going to go into them because my computer can't handle these photogrammic models and running OBS at the same time, but I am going to provide the PowerPoint so that you can see them yourself. So these are all just different examples of what photogrammetry can do. It was extremely enlightening to see the photogrammic fruit and something like the small museum or the monastery, and even the face model. It's just amazing to see what we can do with pictures and make them actual models that can be used. So it's just out of this world. But you can see that if you click the links yourselves. So that's the end of my slideshow. Ultimately, this was an introduction to photogrammetry, and in my next presentation, I'm going to be delving more into reality capture itself. So I hope you learned about photogrammetry. I know I sure did, and I hope you have an understanding of what it is and what it does in the game industry.